Hi, Nasir. Can you hear me? Okay. Hi, Nilesh. Can you hear me?
Yes, you are audible. How are you? Hello.
Awesome. Yes. Hi. Can you hear
Am,
me?
yes, am I audible?
Yes. Yes.
How are you?
I'm good. I just want to ask, are you guys able to access the link
Right now,
comfortably? Like,
yes.
okay, because one student has emailed the professor Vivek because asking about something. So I was
Actually,
thinking
I'm
if
not
the
able
email
to.
is not
Actually, I'm
working.
not able to access the link from the office. That's why I come to home and use my
Okay.
mobile phone to access the link. So right now, yes, I'm
Have
able to
you have
access
you
the link.
emailed the professor or another person? Yes.
Regarding what?
Regarding the access link.
Yes, it is a last week, I think, mail.
Okay, last
When
week email.
I'm not able to access the mail
Okay.
link. Yeah.
Do you know Hitesh?
No.
No. Okay. All right. Okay, let's wait for some minutes and then we will start. So,
For this session, I request you to kindly
yes,
solve
that's
the
you have
assignment
sent me
questions.
an assignment on email,
Yes.
Nilesh. You
Yes.
were the
Yes.
one. Okay.
I already talked
Yeah,
to
I will.
the sir regarding the same,
Yeah,
but
I
we are
will.
not
I
able.
will do some
Fine, thank you.
questions.
Fine, thank you. Thank you.
But I have covered almost all the theory, so I will cover some questions and then we will go for least square method, maybe.
Uh, mm, am I audible?
Yes, yes.
Actually, I am attending four of the NPTEL courses. In rest
Yeah.
of the three courses, they are actually giving a detailed solution of each and every assignment after the deadline is over of assignments. But we are not getting for this particular course. I also request the sir to provide a detailed solution of each and every assignments, so we can see where we are getting mistakes and we are not getting the answers. So it is possible
Okay,
to provide all.
I will email the professor Vivek.
Fine. Thank you so much. Thank you.
Okay, so let me share the screen. All right, so discuss some questions. Okay, I just used some another pen. So we have covered like, so what, okay, questions related to previous approximation methods we have discussed. Yeah, so we will discuss that. It may be helpful for your assignment 9 as well. So the questions will be there, like approximately same. So I'm just doing the same questions. So the first question, if you, yeah, I just write that. So the question is find unique polynomial. So you may be confused by this word unique. I will let you know this one. Px of degree 2 or less such that p0 is -2, p1 is let's say 3, and p2 is let's say 4, then what will be the coefficient of x? So if you look at this one, yeah, it might be, why is that? Okay. All right, so if you look at this one, then this question is saying about finding a polynomial of degree 2 or less such that you are giving 3 points. So that I've already described is that these are the points 0 at 0 and 1 at 4. This is kind of a function and you have to approximate using a polynomial px. So since there are 3 points,
Zero,
so
one,
it
and
should be
2, not 4. Am I right?
what?
0, 1, and 2, not 4.
Where is that? 0, 1 and 2. Why is you are saying about the a question that I
And
framed myself.
no, no, you write a 0, 1, and 4. I think it is 0, 1,
Oh,
and
yeah, yeah,
2.
yeah. Here it is 2. Yes. So it should be 4 minus 2 and whatever is. So it's just for visualizing. I'm not referring to particular values over the graph, but it's just for visualization. Yes. So if you have set of data points, then you have to approximate using a polynomial px. So I have already told you the method that we have described using. Okay. So if I go over in the book, then you see this Lagrangian polynomials that I've already discussed, like how to find such polynomial of degree 2. So here they are finding for degree 3. So you just have to stop at x minus x2 and then you have to remove x minus x3 and whatever, because there are only 3 points, x naught, x1 and x2, and f naught, f1, f2 are already given to you. So just try this question for 5 to 10 minutes, 5 to 6 minutes, and let me know the answer of this. And I will also solve this. Do you know about this method? Okay, just go with that.
Sir,
Yes.
nothing, sir. I just wanted you to share the question. Thank you. Thank you.
Okay.
Yeah, share the question.
Sir, if it is possible to share the formula page.
Yes.
Will you please share the formula page?
Oh, sure. But you should remember this formula as well.
Yes.
Okay, fine. Like that. Let me see. That's interesting. Okay, okay, let me share this screen. In this book, let's go here. Interpolation and curve fitting. Okay. Yes, this is the formula and this is the just go. Yes. What's the answer? Okay.
Sir, just 2 minutes.
All right. That would be interesting. Like you should also know how these formulas are coming. I'm not showing this, but you should also understand.
Sorry.
Yes,
Sir, answer is minus 2x square plus 7x minus 2.
Yeah, correct. Same I got, sir. And x square will
minus
be
2. I just write once. Minus 2x squared plus 7x.
Minus 2.
yes,
So it should be 7. So you understood how you got this?
yes, yes. This is not a problem. Cubic span is a problem. That is a
Okay.
doubt. Waiting for
Okay.
cubic span. Other.
That's interesting. So you just have to use this formula over there. So if just a recap, if you have n points, then you just know. But if you have 3 points, then you know. Skip this first. Yes, x minus x1, x minus x2, and x naught minus x1, x naught. What's this? X naught, x minus x naught. Yes. And these you have f naught. Plus similarly, you have another x minus x2, x minus x naught, and you divide by x1 minus x2, x1 minus x naught, like this, and you have f1 like this. So we'll get kind of this quadratic. So it is p2 basically. Depends on the number of points, you can extend it to further. Why it's called as unique? Can anyone describe that?
But sir, answer is not coming the same. Or in option, it is not. Please solve the all the one detail question.
Answer is not coming. Which question you are saying?
This
Please.
question only. This question only.
Answer is
Option
not
in
coming, right?
option it is, yeah, in option it is not there. 7 is
Which
number is not
option?
there. The question is asked na. Okay, find the unique polynomial of p of x of degree 2 or less.
Yeah,
What will
yeah.
be the coefficient of x in px?
Okay. So coefficient of x will be is just 7, right?
It is not there in option. So I think my answer is not correct.
Which option you are saying about? I don't know.
Uh,
In the
uh,
assignment, it's not the
yes.
assignment question. I've it's not exactly the same.
Okay, fine, fine. Okay,
I cannot solve the assignment question in the
fine, fine.
tutorial.
Got it. Okay, okay.
Yeah.
Similar question. Okay, fine. Got it.
Similar digits so that you can easily solve it.
Fine. Got it. Thank you. Okay.
Yeah. Just follow the similar things and then.
Agree. Agree. Okay.
Yeah. But I'm doing the related to assignment so that you can solve easily. Yeah. Okay. Okay. So next question I'm giving you similar to that. Let me give. Okay. Question two is. So I have already given this kind of similar, but it may be scribble like a natural cubic spline.
Sir, you are explaining about unique. Why it is unique?
Yeah. I was describing. Oh, sorry. Yes. So why it's unique? Because if you look at this, do you have this book
It is there in that
in the
Google.
drive link?
Yeah, it is there, sir. Yeah, it is there with us.
Okay. So if you go to, yes, if you go to error of interpolation, then you will find it here somewhere that these polynomials are. So how much is p and x different to f of x? So if you go there, then you will see that this is the same. You will get the same error basically. If you approximate by any polynomial, you are going to get the same error given by this function ex. Just go through this proof of this book. You will get this. So if you are approximating either using Lagrangian or any other method, you're gonna get the same error using the polynomials basically. So And if you're really interested to see a theorem based on that, then there is a Weierstrass theorem which says that continuous function can be approximated by the sequence of polynomials, unique polynomials. You can just look at that if you're really interested. Okay, I just write the question. Okay, a natural cubic spline S on 0, 2 is given by Sx equals to S mod x, S1x equals to 1 plus 2x minus x. Okay, it's cube, and it is 2 plus b. Okay, just take it x minus 1 plus 2c x minus 1 squared plus 3d cube. Then this for x between 0 and 1, x between 1 and 2. Then find your b, c, and d. What are these values? Just try this, and it is based on cubic spline that I've already seen. I've already discussed this in the last class, where and in the lectures always you have this. So I assume you know what is cubic spline and natural cubic spline means. All right, just try to solve this. Okay, give it a go.
Hello.
Yes. Have you done that?
Not able to solve, sir.
Oh, okay. I just discussed now. Why is that? Okay. All right. So if it is a, you have to solve it and find the values of B, C, D. Okay. So there are some conditions based on that that you should remember that I've already discussed as well. I think I do have this file, recent documents, tutorial 8. Oh, okay, I can't save it. All right. Okay, so how many coefficients you have? You have 3 coefficients. So you just need 3 conditions to solve. So what are those 3 conditions where you can interplay with those? So the first condition that you can look at is this: at this point, S naught it should be same as S1. So S naught at, I just use blue, S naught S1 should be same as S1 at 1. This is your kind of junction nodes and junction nodes. S naught and S1 are same. S naught equal S1. So what is S naught at 1? Which is 1 plus 2 minus 1, which is just 2, and which is same as at 1 it is 0, which is same as 2. So this condition doesn't give you anything, so it's fine. But another condition you have, S naught prime 1 should be same as S1 prime 1. So what is S naught prime x? So just calculate the derivative of S naught, which is S naught, which is just 2 minus 3x square, and S1 is just, what is that, b plus 4cx minus 1 plus 9d x minus 1 square. Okay, so at 1 this value is just b, so it's just 2 minus 3x square equals to b, 2 minus 3, which is minus 1, equals to b. So you get b equals to minus 1. This is one thing you got. Another condition is, so these are called as continuity conditions. Another condition is S naught double prime 1 should be same as S1 double prime 1. So this will go till second derivative because it is a 3-degree polynomials. If it is 4-degree, you can go up to 3 or order 3 at these points. So S naught at double prime 1 should be same as S1 at double prime 1. So what is S naught at double prime? So here if I write S naught double prime x is just minus 6x, and S1 double prime x is just 4c plus 18d x minus 1. Borrow it from here, so minus 6 is just 4c, which implies c is minus 3 by 2. So you got the value of b, c, and another value you will get is, just use this. Okay, b, c you already got, and another thing is you are getting, you have to find out what is d. So you are exhausted till this point, but you need to find out what is d. So you just use your natural spline condition. So what is this? S naught at 0 should be 0, and it should be, is it? So just look at that once. Okay, where is that? Okay. Yes, so what is the natural spline conditions that we are going to look? Yes, so take S naught equals 0 and Sn, this makes the yarn cubic. So this condition is called natural spline. So you have to put Sn to be 0 in this case. So it just is your S1 should be 0. So S1 at 2 should be 0 basically. So S1 at 2 should be 0. natural spline. So what is S1 at 2 is basically 2 plus B plus 2C plus 3D. So your D should be 2 plus minus 2 minus 3. So B is just your minus 1 and C is just your minus 3 by 2. So it's just minus 2 plus 1 plus 3. 4 minus 2, it is just 2 by 3. Yeah. Is this clear,
Yes,
everyone?
sir. Yes,
Okay.
sir.
All right. So yeah, so there may be similar type of questions based on that and which conditions you have to use. Just be careful about these, and this may become in your exam as well. That's true. Okay, I go with another question that we can discuss, a unique one. I just find out. Okay. Okay, you can try a question based on that. You can find out. Consider the natural cubic spline passing through the points 1, 4, 2, 6, and 3, 8 for function fx. What is the approximation of f1.2? Just try this and yeah. Yes, have you done this? Okay, if yes, then let's go with more details of this. So if you come up with this type of question, although it's very kind of lengthy, it means tons of calculations you have to do a lot because you need to solve. So let's define. So you have function which passes through these points 1, 4, 2, 6, 3, 8. So how you set up your interval? Setting up interval first. Set up the breakup. Set up the breakup intervals. Okay. So how you do that? 1, 2, 3. So the interval will be 1, 2, 3. Yes, and there will be yes. So there will be only two polynomials. So I just use
How we are dividing in 1 to 2 and 2 to 3, sir?
yes because you have 3 points. So you need two breakups, like two intervals only.
So why 1 to 2 and 2 to 3 only?
Yes. So I just go if you have 1, 2, 3, and the function is like this, then you have to separate your you have to find a polynomial which approximates this f over here and this over here. You can't go more further, right? Because you don't have a space. Is this correct? Is this all right?
Okay, sir.
Yeah. So it depends on the points. If you have 4 over here in the data set, then you just go over 4. Depends. But you need
So
to find
please,
out what is,
it
yeah,
is so data set is 1 to 4, 2 to 6, and 3
3,
to 8.
8.
That's so why 1 to 2 and 3 to 4 only? 1 to 2, 2 to 3 only.
Because there is no point on x-axis more.
Uh, okay.
Here it's still 3, so I just wrote this because in the question it's just still 3. So up to this point you have to make the intervals. What is the idea behind cubic spline? You just approximate your function over specific intervals, right? Yes. Okay. If you want to add more intervals, you just need more data points. But the question is saying you just have to find what is f1.2. So it's fine. You just go with this.
So 1 comma 4, that means 1 is a x-axis data, 4 is a y-axis
Yes,
data. Am I
yes,
right?
that's true.
Fine. Okay.
This is
Got it. Got it.
basically f. Yeah, this is f1, f2. Okay. Okay. So voice. All right. So let's me use that one. So what is your polynomial using px? It's given by p1x is basically your ax cube. They are saying about the cubic, natural cubic spline. Ax cube plus bx square plus cx plus d. And another one is p2x, which is yes a1 b1 c1 d1 a2x cube plus square plus c2x plus d2. Okay. So you need to find out what is this a1 b1 c1 d1. So I just mentioned. So how many conditions you need? We need 12 conditions. Is it 12? No. We need 8 conditions because we have 8 coefficients.
8 coefficient, that means A1 to D1 and A2 to D2. Am I right, sir?
Yes, yes. 8 coefficients. AI I from 1 to 2. Okay, AI, BI, CI, DI, basically. Yes. Okay. So what are these 8 conditions is you can tell me that, that's easy. So at this point, 1, 2, and 3, this P1 should be matched at the function value. So given F at 1, 2, 3, F1 is 4, F2 is 6, F3 is 8. So what is P? So you will always, the way you define your cubic polynomial is just that it should match the value of the function at these points, 1, 2, and 3. So P1 should be same as F1, P2 should be same as F2, and P3 is same as F3. So this is your first set of conditions. So you got 3 conditions from that. So how many left? 5. The another thing is you are okay. So at P2 should be same. P12 should be same as P22. Second conditions coming from P12 should be same as P22. P1 prime 2 should be same as P2 prime 2. And P1 double prime 2 should be same as P2 double prime 2. That is your 3 more conditions. And third condition is coming from your natural cubic spline. So that means P1 should be same as 0 and P3 should be same as, what is this? P11 should be same as 0. Wait, is that P13? I think we are having, wait, what is the natural? Okay, the natural cubic spline basically refers to this one over here. So here Sx is double, don't be confused over this because Sx is just G double prime at xn. So G double prime at xi basically. So I just write here. So P1 double prime at 1 and P1 double prime at 3 should be 0. It will give you the 2 more conditions. So 2, 3, and 3. 8 conditions. Is it all right? You got 8 conditions. So just solve these conditions and you will get the values of the coefficients.
Excuse me, sir.
Yes.
Sir, can you just see the previous problem, the one which you have
Yeah.
solved? For
Okay.
that natural spline, have you taken the function to be 0 or second derivative to be 0? Kindly check.
Oh, I think I have taken yeah, because the function was Sx, I was confused. Wait, what we
So
have taken?
now, after this,
Natural spline, yes, it should not be easy. It should be S1 double prime. Yes, so it should not be this. It should be, what is S1 double prime at 2? So it is 4c plus 18d, right? I was confused by Sx. So what is the value of d in this case? D is minus 4c. What is c? C is just minus 3 by 2. So 1 by 3. Okay.
sir, for
Is this?
natural spline, so both the derivative, second derivative at end points
Yes.
should be 0. Am I right?
Yes.
Can we just go to the question 7? The present problem, the not the one which you have just changed. I mean second
This
problem.
one.
Yeah, second problem. Second problem. Uh, second problem,
Okay.
sir.
The previous one. Yes.
Yeah. Okay. This is S double dash of 2. What
Yes.
about the just go to question 7? Uh, so is it not even S second derivative of s at 0 should be also taken into consideration.
Why you should take that? Because you need
Because
to.
now natural spline means at the end, means one of the assumption of natural spline is at the end
Yes.
points second derivative should be 0. Am I right?
Yeah.
So what will be the significance of this? I think in this problem we are not using. Okay, if you take
We are
second
not
derivative,
using another
we are
point.
getting
Yes.
6x or x is equal to 0. Okay, that is not helping us to get any values of a, b. Am I
Yes.
right, sir?
Yes.
Okay, fine. Thank you, sir. Please continue.
Okay. So yes. So in this also we have used this. Yeah. So is it clear? If it is clear, I will move to least square
So, sir,
approx.
P1 derivative of endpoint is equal to 0. And
Yes.
just go to the question sequence. And we can write P2 derivative of 2 at endpoint is also 0, right, sir?
Yes. P2
So
derivative of 3 at endpoint.
3. And in P1 derivative of second derivative of P1 at go to the
1.
down, sir. At 1 is equal to 0. Why 1, sir? Because
1
1 is
is
the
the
endpoint.
starting point. Yes,
Starting
endpoint.
point. Okay. So starting point
Endpoints.
and endpoint of double derivative at 0 is equal to 0, right, sir?
Yes.
Okay.
Yes. Most of the time, this question will become. Okay.
So if possible, sir, please solve. Or we can take this condition and we can solve, right, sir?
Yeah, you can take this condition because it will be a time like 8 byte system. You can solve it, but it will not be like that in your exam. They will not give you so complicated questions. So it's
Fine, sir.
just.
Okay. Okay,
Mhm.
sir. Thank you.
But for assignment, you need to solve it using a MATLAB or something. You can do. Okay. So what I was saying, yes, let's go with least square approximation and try one question based on that. Okay. So
Excuse
this
me,
is,
sir. One last question.
yes.
So the present problem will have totally how many equations now? I think around. Can I just go to the problem, sir? Last problem. One,
Yes.
two. I think. So approximate means around 1, 2, 3, 4, 5.
Total 8 equations are there, right? 8 unknown and 8 equations.
Yes.
So, sir, but in examination, without using software, how are you going to solve, sir?
No, in the
Because
exam you will be asked such type of questions. It's
okay,
just
because
for
maximum we can go for 3 cross 3.
maximum for 4 by 4 or four coefficients, I think maximum you can.
But
Sir, scientific calculator is allowed in the examination.
It's not allowed.
because usually maximum we can go for 3 cross 3 because
Mm.
for 4 cross 4 evaluation of determinant, because usually we'll be using matrix method to solve the system of linear equation x equal to a inverse into b, which where a inverse is adjoint a by determinant of a, and determinant of a we can go maximum for 3, no?
I think so. If they go with 4 by 4, then this matrix will be like easy to handle in that case. So
Because
you should not
adjoint
worry.
will not be so easy. Or because for this itself will take around 5 to 6 minutes for 3 cross 3. Okay, sir. Just see.
Mm.
Thank you, sir.
But I think so in the exam they won't be asking such. If the matrix may have more zeros so that you can find out the coefficients easily. That can happen. Or maybe upper triangular, lower triangular matrix can be possible for 4 by 4. That would be easy to find. Okay. All right. So what is least square approximation is that suppose you are given, I think this book I have not shared. I will just do that maybe. So yes. So if this is an example, just go with that. Obtain a least square polynomial approximation to function on interval using least square approximation. So you are given a linear polynomial px a naught x plus a1. Then you consider a function like this, which is the function is x cubed. So you just subtract this polynomial from x cubed, and you do such that this I should be minimum. you minimize this I. I is a functional over, yeah, you minimize this I over X, okay? So the condition to get this minimum is that you take the partial derivative of I with respect to A naught to be 0 and partial derivative of I with respect to A1 should be 0. And then you will get the coefficients of A naught and A1, that is your desired approximation. So that's it. So basically just have your function. So you are basically minimizing your function and the polynomial, squaring the terms and then taking the integration because on the it's defined on interval 0 1, and then taking the partial derivative to get this minimum things and then finding the values. Okay, I just give you one question maybe based on that. Okay. Okay, so this is actually continuous approximation. Okay, let's go with the discrete because in the exam I think they are taking only discrete points. Okay.
Sir, if possible, kindly try to attend all the 10 questions asked in the assignment, similar question.
Yes, I am doing. Yeah. So I've covered most of the questions using of cubic spline and this Lagrangian polynomials in the assignment. If you have any doubts, you can just email me over my email. I will be happy to do that. Yeah. So I'm going with the least square method so that you can understand it now. Yeah. Okay. So the most common question that is asked in your assignment and your exam is basically given the function, given the discrete points like from 0, 1 to n, the function is defined over that. You have to find out the least square straight line or quadratic polynomial approximation using that. So px is c0 plus c1x, we straight line approximation. Then you just subtract your function over this polynomial such that it's minimized. So again, you take the same case that is in the continuous case, del I by del c0, del I by del c1 to be 0. Then you get this some sort of equations to simplify. Okay, so I'm just giving you one question based on that. Okay, so in your assignment I'm just discussing. I think there is one question. Okay, okay, so there is one question like this, just use for it, least square. So you're given some values, say x, y, say 1, 2, 3, 4, and maybe just take 1, 2, 3, simplicity. And you have 2, 4, 8. Okay. Then what is the least square approximation of form y is equal to a to the power bx for given data? Just try to find out. So what you have to do, you have to use this function instead of the polynomial. Okay, so if I go there, yes, any problems? Yes, so you just have to minimize over this. So I just show this type of thing over here. Okay, Px is c0 plus c1x is your straight line approximation, and you just subtract f of xi by c0 plus c1xi and just minimize this square. This is summation, I think I equals 0 to n. So I just write out this here. Okay. So y is your fx, x, yes. So, and how many points you have? 3 points. Summation I equal 1, 2, 3, and you have fxi minus a to the power bxi square. This should be your I. Okay, and then according to this, you have to minimize this I in this case. So minimize it. So how do you do that? So you just take del I by del A equals to 0, because there is, so if you see here, then there are also c0 and c1, these coefficients in your polynomial. So you just have to do this, and del I by del B equals to 0. Okay, so you just take the partial derivative of I. Okay, so how do you do that? 2fxi. Okay, if I go with this one, I think what they are doing. Yes. Okay. So you just have to differentiate basically fxi minus a to the power bxi, and this is just minus e to the power bxi equals to 0. And exponential function is always positive. So you have 2, it is just fxi minus a to the power bxi equals to 0. And another term is del I by del b to be 0, which means yes, so it is just minus ab. Okay.
So what about summation sign?
What's that? Oh,
What about
this one?
summation sign?
Yes. Okay. Yes, that sign should be there. Yes, of course. Summation I equal 1, 2, 3. So you have to sum up with all the data points, right? You can do this. Another equation is, so you can differentiate, you can calculate del I by del B yourself. Okay, I just go. So this is for, yes, another one is just the same thing over there. I equal 1, 2, 3 fxi minus a to the power bxi, and this is just minus ab to the power bxi equals to 0. So you got something like this and something like this. So this e to the power bxi can be managed. So you get something. I don't know why this question is in your exam, in your assignment. Okay. Okay, so you just try to solve these two things, 1 and 2. Find A and B using 1 and 2. It's kind of non-linear equation, okay?
So what is the value of fxi we have to put?
Xi's are your x1 is basically your data points. Okay, I just write x1, x2, x3. Is that all right? 1, 2, 3. X1, x2, x3, and
And
fx1 is,
fxi is okay.
yes, y is fx, so fx1. Okay. So just substitute these values over here. You can use MATLAB maybe in this case. Yes. but I would say wait. Okay, this is the usual way, but if you want to go with some finding these coefficients over here, this is a tricky one. So I'm just going to show. Okay, I understand. So you have kind of this approximation to function, which is kind of px to u. So you take log px. So log px will give you log a plus p log x. What is this? Log a plus px, because log e is 1. So you just use log px instead of log a plus px. So whatever I've done with this function, just try to do with the logarithm of y, log y, and try to find out the coefficients. Is this clear? Because it would be easy to solve after that. Yes.
So if it is possible to kindly solve with the log.
Okay. Okay, so just consider with, because it, you see the problem, right? This is kind of non-linear equation. You won't be able to solve it. So in the exam point of view, it is hard for you. So just use the log function, log a plus px, log of this polynomial, and do the same thing. Like, so your I will be the same, but a little bit different, of course. So fix minus log a plus bxi square. Okay. Then you calculate what is log I del I by del a, which is just, okay. What is the derivative of this? 2 fix minus log a bxi. Log a, derivative of log a, what is this? 1 by a, and b is basically 0. So 1 by a equals to 0. Okay. A is, assume a is non-zero. So this will over reduce it. And another is okay, so this is one equation you got, and another equation is you got del I by del b equals 0. So 2 same as this. Bxi, and the derivative of partial derivative of this is 0. So it is just x del I by del b, which is just xi equals to 0. Okay. So you just solve these equations by transferring the values, and of course there is some. So it's kind of linear xi square basically. So you can find values of log a and b. Can you do that? It's easy, right? Now you have all the values, and it's kind of system of two equations. Is this clear? Because in your assignment it's such type of question, and you have to do that. You have fixi, you have xi is already given to you. Just substitute in this del I by del a and del I by del b. Then find out these values of log a and b. That's it. And once you get log a, so you have log a, then you can get what is, so suppose log a is 5, then a is basically e to the power 5. Let. So you just have to do in this way. Okay, because that way was complicated, this is non-linear equations, but here you are getting a linear system, so it's easy to solve. I hope it's clear now. Any doubts?
No, sir.
Okay.
So answer will be after finding A and B, it is my answer, right? We have to
Yes.
put in the equation.
Yes. So if you see any complicated equation like for with exponential functions, just take logarithm of that before fitting it. Okay. That's make it more easier. Any other doubts?
For this question, no, sir.
Okay. Others? It was like 10 to 15 minutes for doubts.
Sir, will you please solve the question similar to question number 8 in assignment?
Okay, wait. Consider. I cannot solve that exactly, but I can help you. Okay.
Yes, yes, similar kind of question, yes.
Okay. Wait. So you have question. Consider the following table. You are given some kind of table, okay? XY, which is has values 1, 2 up to 1, 2, 3 up to 10, or 1, 2, 3 maybe, whatever these values. And so yes, this is given to you. You have to find out what is A, and you are given Px to be a linear approximation A naught plus A1x. Pure linear approximation, least square approximation of first degree, such that integration of 0 to 1 Px is some number like 5. What is the value of A in this case? So it's easy, isn't it? So can you find out these A naught and A1 using least square? Find A naught and A1 using least square approximation. This is the first step. Just follow the same procedure that I've shown here. Is this clear? So what you have to do, I just show. So you have what is the I in this case? I is just fx. Sorry, I just use y in this case. Maybe that would be good. Y minus pxi, yi minus pxi square, summation I equal 1 to 10. So you have to minimize your I, minimize over a naught and a1. So you take del I by del a1 equals to 0, and del I by del a2 equals to 0. Sorry, a naught a1. So once you get that, then you can easily differentiate it, partially differentiate it, find a naught and a1 from linear system. And then if you got this, then you are obviously, it's a straightforward then. So a naught or a1 must be in terms of a. A is unknown, right? So you have kind of something like a plus 6 equals to 5. Then you can find A. Yes, is this clear, Nilesh, specifically?
Yes, sir. We'll solve the question. If any doubts is there, we'll write an email.
All right.
So I can just show the last slide, sir.
Yes. What's the doubt?
Just a bit above that summation.
Yes.
Okay. So after we differentiate, that's what just below. After that, find a naught and a1 for level. So
Yes.
if you differentiate the above, surely we'll get summation. So we have to apply the summation, and I think that will give it to in each. So in each equation, summation will be there, and then we are going to apply summation, and then get two equations, two unknown.
Yes. Yes.
Right? Okay, sir. Sir, one more thing was I just saw. What is this clamped spline, sir? Because in assignment it is also the clamped spline. Can just take one
Yes.
problem on that clamped spline. Question
Okay.
number.
Clamp this line that I've already shown to you before, but I would just in
Yeah,
the last
please.
lab tutorial. I think I haven't shown you. Okay. I just save it first.
And sir, are we going to get this video by today maximum?
Yeah. Yeah. Sure.
Because
If
it
you
will be
want.
very helpful to solve the assignment problem, to compare
Yes.
or again to go through it.
Okay,
So today can we expect, sir?
yeah.
Yeah, thank you.
Okay, tutorial 9 is.
So also request you to kindly provide the detailed solution of all each and every assignment, sir.
Yeah, I have emailed to the
Thanks.
professor.
Thank you.
Okay, I just check I have just saved it or not. Where is that? Okay, it's saved. So I've just tutorial 8. Okay. We have discussed this, I think, and natural spline. And what about the cubic spline? Clamped spline, yes. Okay. So the clamped spline condition is this one, where you have. So if you are given such type of polynomials, z naught up to gn, then you take g naught double prime x naught to be g1 double prime x1. So you take at this point should be same as this point, the double derivatives. And another condition is gn minus 1 double prime xn should be same as gn minus 2 double prime xn minus 1. So if you go over there, then at this point gn should be same as gn minus 1, means last two polynomials should be same at respective points. Okay. At x naught x1 and at xn and xn minus 1. Is this clear?
Sir, can you kindly take one problem, sir, on
Okay.
clamped
Yeah.
spline?
Yeah, sure. Maybe I just have assignment. Okay, in this problem we had. Okay, suppose in this you have to use the clamped spline conditions, then what should be this? So there is. So in this problem there is only one condition over clamped spline that. Okay, I just. So clamped spline in this is S naught double prime at 0 should be same as S1 double prime at 1. Okay. Instead of, so S naught double prime 0 is not 0. Instead it is same as the second polynomial that you have at 1. Likewise, yeah. And it's also similarly, if you go in at the endpoints as well, then it just replies the same thing. S1 double prime at 1 should be same as S naught double prime at 0. Yeah. Is this clear?
Sir, but in assignment they have talked about first derivative, sir.
Which derivative?
First derivative.
Which one is that?
Question number 3.
Consider the clamped spline conditions passing through the same points as given in with. Is this already defined or what? Okay. Means these are the standard clamp conditions, but if they are defining some conditions specifically, then you have to use them.
Okay.
Yes, but they are standard ones. But if in
So
the
if it is
question,
possible to solve the question related to 3, because I am also having the same doubt.
okay, so if you have this, because these are the two conditions that you have, wait. So this clamp spline condition, this is a standard one. It is just giving you only one kind of equation, right? So, but natural cubic spline give you two conditions, which I've already discussed, S naught double prime and S1 double prime 2 at 0. So in the third question, it's still giving you the same things. So instead of that, it's just, you just have this S S prime 1. So instead of these natural spline conditions, just use these conditions. These are also two conditions. You can just find out that. Can you do that? No. You just have to replace the natural spline with these conditions. That's it. Okay, so if you go there, then you have this. What is given to you? You are already given S prime 1 equals to 2. It means that S naught prime 1 equals to 2. So here you are taking S naught prime 1 same as S1 prime 1, but it is basically same as 2. So, but if this condition is conflicting in that case, but yeah, wait. Isn't it? S prime 1 is 2. What is S naught prime 1? Okay, then yeah, I have taken the different question. That's why it's different a bit. But yes, it should be same. Then B should be same as 2. And in your assignment, yeah. Yes, any more doubts? So the simple thing is that, in summary, that if the question is defining the conditions other than natural spline, if it says natural, then it means standard equations. Okay. And clamped, of course, it's standard, but if they specifically mention that you have to use this condition, then just use that. That's it. I hope it's clear. Any more doubts? Okay, thanks for your time, and I'm closing the session now.
Thank you, sir, for your time.
Yeah.